Welcome to Module 9 in the series of courses on network cabling systems. Today we'll be talking about network conductivity in terms of network access and transmission methods. Once again, I'm Ted Chandler, your instructor for this online course. In this module, you will learn to first recognize simple and complex physical topologies used in data networks. You'll also be able to describe Ethernet and the CSMA-CD network access method, understand the different types of Ethernet access methods, describe the techniques used in the token ring, ATM, and FIDI network access methods, and finally you'll be able to identify the main characteristics of network transmission methods such as X.25, frame relay, T-carriers, ISDN, DSL, cable, and SONET. Three simple physical topologies, or the layout of nodes in a network, exist. They include the bus, the star, and the ring. Few organizations use simple physical topologies, however, but rather use a hybrid of these simple shapes. The star-wired bus hybrid topology is commonly used on modern Ethernet networks. The star-wired ring hybrid topology is commonly used on modern token ring networks. Mesh topologies in which nodes are directly connected to more than one other node are commonly used on WANs or wide area networks. Ethernet, as specified in IEEE 802.3 standard, is a network access method that uses carrier-sense multiple access with collision detection, or CSMA-CD, to determine how multiple nodes share a single channel. Depending on the type, Ethernet may run over fiber optic cable or twisted pair wiring. Ethernet offers between 10 megabits per second and 10 gigabits per second throughput. Ethernet types include 10 base T, 10 base F, 100 base T, 100 base F, and 10 gigabit Ethernet. The 10 represents a maximum throughput of 10 megabits per second, and 100 represents a maximum throughput of 100 megabits per second. Base means baseband transmission for a transmission form in which digital signals are sent through direct current DC pulses applied to the wire. In Ethernet shorthand, T represents twisted pair and F represents fiber optics cable, the technology's medium. Most Ethernet networks currently use baseband transmission and the star-wired but hybrid topologies. Ethernet specifies protocols at the physical and data link layers of the OSI model that determine how multiple nodes share a single network channel. Ethernet is by far the most popular network access method. CSMA-CD, or Carrier Sensing Multiple Access Collision Detection, are the rules for communication used by shared Ethernet networks. Carrier sensing means that the station listens for activity. If it hears no activity, it will transmit. If it does hear activity, it waits and tries again later. If a collision is detected, transmission stops, waits an arbitrary period of time, then retransmits. Multiple access refers to the fact that Ethernet nodes can be connected to a network and can monitor and issue traffic. Today's Ethernets use switches rather than hubs because switches are far superior in performance and value. Hubs are simple pass-on devices that broadcast to all nodes at the same time, so all nodes on the network hear the transmission, causing a lot of traffic with each transmission. Switches are intelligent devices that transmit directly from sender to receiver, often in the full duplex, or send and receive simultaneously. Token ring is a network access method originally designed by IBM and now specified by IEEE in its 802.5 project. Token ring uses token passing to determine which nodes may transmit over a shared channel. It comes in 4, 16, and 100 megabits per second versions and typically runs over UTP and relies on the star-wired hybrid topology. Token ring is less popular than Ethernet, and no new token ring networks are being installed today. Fiber Distributed Data Interface, or FDDI, is a 100 megabits per second network access method that runs over double fiber optic rings. Its primary advantage is its reliability, because if one of its rings suffers a fault, data automatically reroutes over the second ring. FDDI was a popular choice for MANs in the late 1980s and early 1990s, when it was essentially the only 100 megabit per second solution. Asynchronous transfer mode, or ATM, is a unique networking topology that uses fixed packets called cells and virtual circuits to transmit information at rates up to 9.95 gigabits per second. It is primarily used on large network backbones, such as those operated by network service providers. One significant advantage to ATM is that it can guarantee quality of service, or QoS, which makes it appropriate for voice and video applications. X.25 and frame relay are packet switch topologies or technologies that rely on the PSTN to deliver data at higher rates than an ordinary telephone line. X.25 is analog, whereas frame relay is digital. Also, X.25 guarantees accurate data delivery, and frame relay does not. X.25, therefore, is slower than frame relay. Both are economical solutions for WAN links. Integrated Service Digital Network, or ISDN, is a dedicated digital network transmission method that runs over PSTN lines. It comes in 3 varieties: PRI, BRI, and BISDN. PRI, which offers a maximum throughput of 128 gigabits per second, is a popular choice among telecommuters. T-carriers refer to any transmission method that uses the multiplexing and digitizing techniques first developed by AT&T in 1957 to digitize voice signals. The most popular T-carriers for business use are T1s, with a capacity of 1.544 megabits per second, and T3s, which with a capacity of 45 megabits per second. T-carriers are dedicated leased lines that may run over twisted pair or fiber optic cable or wireless links. They are classified according to their digital signal, or DS signal, where DSO equals 164 kilobits per second channel. A T1 contains 24 of these channels. Multiplexers are devices that combines voice and data signals on one line. CSU, DSU, or Channel Service Unit, Data Service Unit, is the connection point for a T-carrier line at the customer site. CSU provides termination monitoring. DSU converts the digital signals used by bridges, routers, and multiplexers into the digital signals sent via the cable. T1 technology can be unshielded or shielded twisted pair copper wire. Digital subscriber line, or DSL, is a transmission method that uses advanced data modulation techniques to achieve extraordinary throughput over regular phone lines. It comes in several different varieties. Each type has a unique signaling method and as a result offers a different throughput. Some are asymmetric like ADSL, whereas others are symmetrical like SDSL. DSL is a dedicated service. It competes with ISDN and cable technology. Cable technology uses the existing cable TV infrastructure to offer subscribers access to the Internet. To accomplish this, cable companies must upgrade their networks to allow bidirectional signaling. Cable is an asymmetric technology that offers at least as much throughput as a T1 for much less money. However, cable is a shared network, meaning that an entire neighborhood may share a fixed amount of bandwidth. Synchronous optical network, or SONET, is a transmission method that can provide data transfer rates from 64 gigabits per second to 39.8 gigabits per second using the same TDM techniques used by T-carriers. It relies on a dual optical ring similar to FDDI technology. This makes it highly fault tolerant. The SONET rings are costly and are typically used by telecommunications carriers or very large organizations. In summary, we discussed in this module 3 simple physical topologies, which are bus, star, and ring. We also talked about Ethernet as a network access method that uses carrier sensing multiple access with collision detection to determine how multiple nodes share a single channel. We also talked about Token Ring, which is a network access method originally designed by IBM and now specified by IEEE in its 802.5 project. And finally, we talked about digital subscriber lines, or DSLs, as a transmission method that uses advanced data modulation techniques to achieve extraordinary throughput over regular phone lines. And it comes in several different varieties. This concludes Module 9. Please take Quiz 9 and advance to Module 10, where I'll see you in Module 10.